Hello everyone. So let's see how to solve today's question. So today's question is find minimum time to reach last room 2. So this is the part 2 of the problem. Find the minimum time to reach last room. So the first one is also similar. If you want the explanation for that, I'll be happy to do that. But let's first go through this one, and I think you should be able to do it on your own once we are done with this. So there is a dungeon with n cross m rooms arranged as a grid. You are given a 2D array move time of size n cross m, where move time ij represents the minimum time in seconds when you can start moving to that room. So suppose if you have a room, let's say some A room is there, so that room gets opened after like some t time. Okay, so that t time information will be given in this move time ij for that room, at what time that room will be open, and for moving from one room to other room you will be required 1 second of time to make this transition. Okay, so you start from the room 00 at time t equals to 0 and can move to an adjacent room. So if you have a room over here, this A room, you can move to any of its adjacent room. So the adjacent rooms are this only, like these four: this one, and this one. Okay, because it's a grid, so these four are the adjacent ones. Moving between adjacent room takes 1 second for one move and 2 seconds from the for the next. Okay, so if you move from, suppose if you are taking some path from A room, you move to some B room. So this move will cost you 1 second. Okay, but then if you move from B to C, then this will cost you 2 seconds. And then if you again go to some D room, it will again cost you 1 second. And if you then from over here, if you move to some another room, it will cost you 2 seconds. So this second will be alternating between 1 and 2. So first it will be 1, then it will be 2, then it will be 1, then it will be 2. Return the minimum time to reach the room n minus 1, comma m minus 1. So we need to reach the last grid position. So if the grid is like this, so we need to reach this grid from starting from here. Two rooms are adjacent if they share a common wall, either horizontally or vertically. Okay, so as I told you, if there is a room like this, so these are the rooms which are sharing its wall. Okay, so all the four direction, these are the adjacent ones. So now let's take some example and let's see how it's the answer getting generated for that. So, but first let's see first few things. So suppose if you are moving from some room A to some room B, and the time you have taken to reach this A room is 3. Okay, and then if you have if this B room open after this time, so we have some cases like, so the first case is which we are seeing is if this A room is uh, in reaching this A room, my time taken was less than the time when this B room will be open. So let's say if this B room would get open at 4. So now how much time will I be required for moving from A to B? Okay. So I will have to first of all wait for 4. There is no way before that I can make that transition and I can move to that room. So once that 4 time has elapsed, then what will happen? I will take seconds, like 1 second or two second based on my previous second. So I will make 1 second move, let's say. So then it will be 4 plus 1. So in reaching this B room, my time will be 5 seconds, okay, for moving from this A3 to B room with an opening time of 5. So this will take me 5 seconds. Why? Because at 4 seconds it will get open and then 1 second for the transition. Okay. And let's say there is one more case, like if A, this is B. Suppose Suppose if in reaching A, you have already taken 5 seconds, and then this B room gets opened at 4 seconds. So now how much time will it take you to make this transition? So you will need 5 plus 1. So till here, if you wanted to reach, you have already reached over this B it, at this A room in 5 seconds, and for moving from this A to B, you will be just require 1 second. Why? Because this B room will already be open by that time. Okay, so you won't require any more time. So the total time will be this 5 plus 1. I hope you are able to get it. So there are two cases. Okay, so how can we, how to decide like when I will be reaching the next room? So that I can simply, if we can take, it will be max of, it will be max of like this 5 plus 1. So the time of A, like if we write it like TA plus 1, comma TB plus 1, it will be the max of this. If you take this above to example, you can see like it is true, this equation holds true. So we'll be using this further. So this is how we can get the time. So now let's see one two examples for the same, and we will then come to the solution. So, and also like in these is structures where there is a grid and all, and you have like four adjacent neighbors, I think you, if you have solved some previous question like this, then you can straight think like this is a graph kind of thing which we are dealing with. And if you can think like if it's a graph, then if I need to reach a position in a graph at a node with minimum time, then we can use Dijkstra algorithm for it. Okay, so we'll be using that. But let's just first this let's see this example like how the answer is being generated for this. So we have this 0, 4, 4, and 4. So I can from this, I will be starting from this position. So starting from this to reach this, how much time will I take? So in the beginning, my time is 0, but this room gets open at 4. So this room gets open at 4, and plus in the starting move, I will be taking second time to make the transition. So my time will be nothing but 4 plus 1 equals to 5. Okay, so as you can see, at time t equals to 4, move from room 0 0 to room 10 in 1 second. So by that time, we will be having the time t equals to 5, as you can see. So in the next room, so in the next, what will we do? So once we have reached this or this, then we'll be making the next jump for the next room. So once I have already elapsed the time of 5, then I don't need to wait for this room to open. So I'll be just taking one more second, and I'll be making this transition. So this will be 5 plus 1, so this will give me 6. So this will give me 6. But if you remember in the question, it was given like the alternating of seconds for each transition is there. So for the first transition, we took 1 second, but for the next transition, we'll be required to take 2 seconds. So the answer will be 7. Okay, because in each transition, we need to alternate between 1 second and 2 second move. Okay, so that's how the answer for this is getting generated. Simply, you can also like go through the other examples, and similar way the answer is for them also. So as I previously told you, we can solve this with Dijkstra. So what's the time complexity of Dijkstra? It's v plus e log v. So if you take the total number of edges in this v plus e, if you just consider this e, so what can be the at most the number of edges? So n cross m into 4 will be the number of edges. So each cell in the grid can have at most 4 neighbors. So that value will be around like this value will be there. So this is the v plus e, and if you multiply it with log of n cross m into 4, okay, the total number of cells, or if you even multiply with e, that just, if we even if we multiply it with the verse, so then also you will be getting this value, and it is less than 10 to the power 8. Okay, this is less than 10 to the power 8, so this will work. This is about 4 into 10 to the power 7 something value. So this is less than that. Okay, so this will work. So now let's see the solution. So in the solution, what I have done is I have taken the total number of rows, I have taken the columns, I have taken the visited array, and I have taken the direction. So, but all directions at each cell I can make the move. So these four directions I have stored in my directions array. I have taken a priority queue to did decide, like, if suppose I have like three choices in my queue, so I will be picking up the choice with the minimum time. So based on this minimum time, I'll be deciding to which next cell I need to make the move. So suppose if this was 2, this was 5, this was 4, then I'll be picking up this one, and from here I'll be taking the next shortest path. Okay, so what I have done is, in the queue I'll be adding a array of integers. So this array will be always having four values. What will be the values? The row, the column, the time, and the second. Okay, second which I'll be using for the current transition. So okay, so in the beginning, the second which I'll be using is 1 second, because the first transition will happen with 1 second only. So now I have marked this 00 as true because I have already visited this, and I'm adding this in the queue. Then I've just done the extra algorithm steps. I have iterated over the queue. I have removed from the queue, and I'm just checking if I have reached the last cell. Then I'll be just returning this the time. So the time is at 0, 1, 2 at this position. So I'll be returning the time, and also like how the priority queue is using this information, it's comparing the things based on the time. So the time is at the second position, so this second position is being compared, and I'll be getting the minimum time. Okay, so then I'm just doing nothing, but I'm just iterating over all of its neighbors. The neighbors can be generated by iterating over the direction array, and I'm iterating over the direction array. I'll be getting a new row, a new column, and I'm checking if it's a valid one. So the valid condition is over here, like, so if the current row is greater than equals to 0, and the also the column is greater than equals to 0, and if it is less than the rows, and if it is less than the column, so then it's a valid value, and I am returning that. So after that, I'm just adding it in the queue. So the new row, new column, and as I told you earlier, my formula was the mat.max which we discussed earlier. The transition time will be nothing but my current time plus my transition time, or the time at which the next room will get opened, plus the transition time. So out of these max values, out of these two max values, I'll be getting my result. And after that, once suppose if I have used this 1 second transition for now, then the next one should use 2, so that I have stored it, like, if the current one is 1, if the current transition which I am using is of 1 second, then the next one should use the 2, or it should use the 1, and I'm then just marking the visitor as true. So that's how I'm just doing the Dijkstra. And we have already discussed the time complexity. The space complexity will be also just n cross m, order of n cross m. So because we are using this priority queue. So yeah, so yes, we have solved it. I hope I was able to make you understand the solution and how I arrived at the solution, and the things are clear. So yeah, that's about it. Thank you.